අයියෝ only two sides නෑ නෑ තව ගොඩක් තියෙනවා. Right. So page number 1 then. Force. A force is, you can write the meaning of a force using 3 words. Middle one is ORO. Something O something, and both things are starting with P. एक को आवाज दिन लगता तालु करने को pull or push लो. Yeah, what is a force? Pull or push. If you like to push, you can write push first. Push or pull. Pull or push. Push is a force. Okay, so you can write whatever a force is. If you like to pull things, first you can write pull or push. If you like to push things, then you can write push or pull. Write whatever you like, but write something. Nahi tano ne push li under the pull li under this la. Kya clear? But write something. You can write push or pull. Natham pull or push. Write it. Pen hawa pinne. Take the pen and write. Hurry. 2 places to write. One is in your memory mind. Record there, and next one your. So push or a pull or a push is a force. Hurry the right. Second one, uses of forces are 1, 2, 3, 4. First one, blank which is at rest. Okay, something is at rest. Any object at rest. By applying a force, what can you do? You can simply move it. It is a stop. If you apply enough force, sufficient force, you can move it. Okay, so let's write there. Moving an object. Moving an object which is at rest. Yeah, number 2. Moving an object. By when depa blank clear number 2. Number 2 never ඇත්තටම number 1 නේ. Second blank එක but answer number 1. Blank which is at rest. Let's write there. Moving an object. Moving an object which is at rest. It is at rest, it is stopped, we can move it. Number 2, blank which is in motion. Something is moving already in motion. By applying an enough sufficient force, we can stop it. So you can write stop an object. Stop an object. Highly important. Stop an object which is in motion. Right there. Third one, blank of a moving object. Fourth one, changing the blank of an object. Right, third one, blank of a moving object. Something is moving. We said we can stop it. Other than that, what else can be done using a force when it is moving? Say someone is walking. By applying a force towards the direction of motion, you can increase the speed of motion. By applying a force towards opposite direction, you can reduce the speed of motion, isn't it? So we can increase the speed, velocity, we can decrease the speed, velocity of moving objects by applying a force. පුළුවන් නේ තල්ලු කරොත් තල්ලු වෙලා යයි මෙහෙම ගිහලා ඇද්දොත් එහෙම slow වෙයි. Very simple. Right. Let's write blank of a moving object. Okay, let's write increasing or decreasing the speed. Increasing or decreasing the speed. මොකද හොයන්නේ නින්ද ගියාද? Third one. Third one, what is it? Increasing or decreasing the speed of a moving object, or you can say increasing or decreasing the velocity. Take tutes. Increasing or decreasing the velocity of a moving object. Fourth one, changing the blank of an object. Now I got little angry because I said take the tutes. Hurry. So I can go to him and say, "Deno homber your trend." I am applying a force to change the shape of the homber. Not here. Homber is there. Tute is there. Okay. By applying a force, we can change the shape of homber and other objects. So last one is changing the shape of an object. So by applying a force, you can change the shape of the homber. objects. So last one, changing the, yes, changing the, what did you write? Changing the home button. Changing the shape of an object. Okay, basically these things we can do by applying a force. We can move, we can stop, we can change the speed or velocity, we can change the shape, we can change the direction of motion also, isn't it? Like cricket match, ne? We can change the direction of motion also. Can't we write it here? What did you write for third one? Third one, increasing or decreasing the speed. Can you put a comma there and write direction of motion? Third one, long space. Third one was what? What did you write? Increasing or decreasing the speed. Ne? You can put a comma and write somewhere. Then it becomes increasing or decreasing the speed, comma, changing the direction. Changing the direction. ඒකත් කරන්න පුළුවන් ඈ. Let's add it to third one. කලින් කියන්න බෑනේ. So third one is increasing or decreasing the speed, comma, changing the direction. හරිනේ, changing the direction. Then it is of a moving object. So these are not to by heart remember, just know a force can do these things. Very simple, but I wanted to finish that. Right, now we have two types of forces, balanced forces, unbalanced forces. Very simple but very important. Balanced forces, unbalanced forces. Right, Newton's laws sometimes going with unbalanced forces, sometimes balanced forces. Right, balanced forces are very simple. Very simple. Look at the second photo, second diagram. It is a boat floating on water. Right, floating on water. We know boat is very heavy. How can it float then? You know this one from grade 7. Liquids give something upwards called upthrust. So when this upthrust is equal to weight of the boat, boat can float. Once again, boat is heavy, it pushes water down. Water pushes the boat up. This upward force is called upthrust. Anything, everything, when floating freely, you should know that it is because weight is equal to upthrust. Weight is neutralized by, equalized by upthrust. Then it can float. But if weight is greater, upthrust is smaller, definitely it will sink. හරිද? නිදහසේ පාවෙන ඕනම දෙයක් අයි පාවෙන්නේ කොහමද? weight is equal to upthrust. Ship, boat, anything, anything. Okay, so using this you can understand what is a balanced force. Balanced force means simply when there are two or more forces acting on same thing, if they cancel each other, if they become equal to each other, if they neutralize each other, and finally like nothing, it is called balanced. Tug of war වගේ නේ, අවුරුද්දට කඹා දින්නේ අර teams දෙකක් නේ. If their forces are balanced, they are not going to move to any direction. Balanced forces. හරිද? Very simple. Look at the first one. First one is around you also. Actually you also are doing it. You are sitting on chair ne? Yes. You are giving part of your body weight on chair. Chair is giving same force to your this side. Ne? Maybe now you can't feel. තා චුට්ටක් කියලා යන්කෝ 30 minutes 1 hour 1.5 වෙද්දි නම් යමරනවා මෙහෙම. Why you can feel that? Ne? You can feel that balance force. If chair is unable to give a balance force, chair will break and you will fall down. Don't worry, it won't push you up. You give a force, it gives same force, equal force. Right? නැත්නම් එකපාර විසි වෙන්න ඕන කට්ටිය උඩනේ. If chair's force is greater than your force, නෑ. See, balance forces. Right? Very simple. Balance forces. So first one, look at the first one. It is a book. Imagine it is you. You are giving your weight on the table, and this weight is called, in this unit, action. It's not that film action, not that one. Action means the force applied by you, the first force. So this action is actually weight. Weight is called action. Near action, you can write inside brackets WEIGHT. action later. Near this word action, inside brackets you can write WEIGHT, weight. Hurry. So when this book is giving weight on the table, table is giving a return force. What do we call this return force? Reaction. Reaction. This is not chemistry, chemical reaction. This is physics. Return force, reaction. Okay. Now action is equal to reaction. So forces are balanced. Ne? This book is not falling down. This book is not getting thrown up also. It is there. Why? Downward action is equal to upward reaction. So they are balanced. So on this we can write action equals reaction. Right there, action equals reaction. Or you can write reaction equals action in the blank. Blank එකේ ලියමු action equals reaction නැත්නම් reaction equals action. Equals means balanced, ne? Balanced. So such forces are balanced forces. Come to second diagram. What can you write there? What can you write there? Downward weight is equal to upward upthrust. So you can write weight equals upthrust, or you can write upthrust equals weight. Right. Next blank, second blank. ලියමු second blank එකේ. ඒ ලියන්නේ නැත්තේ. මොකද ලියන්නේ? මොකද ලියන්නේ? action equals reaction ද නෑ. දැන් ලියන්න වෙන්නේ weight equals upthrust. නැත්නම් upthrust equals weight. So understand that when they are equal, we can call them what? Balanced forces. Alright. So let's read and finish balanced forces. May then now itself take these things into your head, right? Because Newton's second law otherwise can be difficult. First also can be difficult. Third one easy. Right. When forces are balanced, there is no change in its state of motion. When forces are balanced, there is no change in its state of motion. State of motion means it is moving or not now. If it is moving, what kind of motion is there? Acceleration, deceleration, uniform velocity. This is called states of motion. Right. One last time. When forces are balanced, there is no change in its state of motion. Now you are stationary now. Ne? පුටුව කඩාගෙන වැඩෙන්නෙත් නැහැ, උඩහට විසි වෙන්නෙත් නැහැ. Stopped. Stationary. Stationary objects remain still and moving objects move at same speed. Unbalanced forces can change the state of motion. හරිද? One last time, take into your head. May these facts are very easy but very important. හොඳට දැන් අහන් ඉන්න ඕනේ. Otherwise first law, second law upset යයි. හරි? හොඳට අහන් ඉන්න. What is it? When forces are balanced, there is no change in its state of motion. Motion doesn't change. Why? Forces cancel each other, kill each other. Stationary objects remain still and moving objects move at same speed. Nothing changes. Unbalanced forces can change the state of motion. If you want to change the state, you need what force? Unbalanced force. So let's go and see what are unbalanced forces. Look at the diagram. Your left hand side team is applying 400 newtons. Right hand side team only 300 newtons. Now there is an unbalanced force. How much? Towards which direction? How much is unbalanced force? 400 minus 300, that means 100. What's the direction? Left hand side or right hand side? Left hand side. Okay. Then unbalanced force. අපි මෙහෙම ලියමු 100 n and then mark an arrow on it towards left. Right. ලියමු unbalanced force එක. Unbalanced force is 100 n towards this direction. Now you can write 100 newtons towards this direction. This way you can show unbalanced force. Right, simple, eh? Unbalanced force. So now you know what is an unbalanced force, you know how to find it. But unbalanced forces, balanced forces, force equilibrium, resultant force, all are in unit 9, 11, 12. We are going to do 3 in 1 tute for that. One tute, unit 9 first, unit 12 next, unit 11 next. ඒ ඔක්කොම forces ගැන තියෙන්නේ. හරි unbalanced forces, balanced forces, force equilibrium, resultant force, shock පාඩම. Right. Now right hand side one. What is there? Parachutist slows down soon after opening the parachute. You know this. Parachutist slows down soon after opening the parachute. Right. Now this parachutist is slowing down, decelerating. Downward weight of the parachutist with parachute is 490 newtons. What can you say about upward force? What do you think? Okay, once again, downward force 490. Upward force is how much? Simple A 490, simple B 480, simple C 500. නිකන් හිතන්නකො. Downward force එක 490යි. Upward force would be how much? Same 490, less than that 480. Upward force greater than that 500. What do you think? Why would this parachutist slow down? Which force is greater? Which force is greater? Downward or upward? Downward. Then parachutist will die. Why? Parachutist will accelerate. Why? When there is an unbalanced force towards a particular direction, towards that direction there is an acceleration. It's Newton's second law. මන්තාම කියලා දුන්නා ඒක. හරි? When there is a force, objects accelerate towards that. Now parachutist is decelerating downwards. Which force should be greater? Upward force. Then don't ask why doesn't parachutist go up then? නෑ එහෙම නෙවෙයි. Upward force is little greater than downward force. Therefore parachutist slows down. If downward force is greater, parachutist should accelerate more and more downwards. Before opening parachute, that's the condition there. Downward force is greater. Because of opening parachute, upward force becomes first greater. Harida. So now I want to write inside this box, say 500 newtons. 500 newtons. චුට්ටක් වැඩි එකක් දාමු. 500 newtons විතර. Right. Okay. Then you can understand that their forces are unbalanced. Right. After discussing Newton's first law, you will agree with what I said now. දැන් හිතනවාදී එහෙම කොහොමද? එහෙම වෙන්නේ. හරි? But after learning first law, according to Sir Isaac Newton, you will understand that. Right. Let's read and finish. When forces are unbalanced, the state of motion can change. We can't say definitely change. Can change. Because now there is an unbalanced force. There is a net force. It can do something. So it can change the state of motion. හරිද? කලින් සැරේ forces මොකුත් තිබ්බේ නැහැ. දැන් තියෙනවා. එයාට පුළුවන් මොනවා හරි වෙනසක් කරන්න, change එකක් කරන්න. Okay? Right. So remember, when there is any kind of change in the state of motion, forces are unbalanced. There is a force. Right. When forces are unbalanced, the state of motion can change. That means stationary objects can move, moving objects can stop or can change the speed. Hurry. Right. Now if you want to do something, if you want to change this world something, we have to have what force? Unbalanced force. Natham, they neutralize each other, can't do anything. Right. Next one is actually from your unit 5. My unit 5 you know what is it? Friction. We have to talk about friction a little here. So I am going to give a brief introduction. Right. Say you want to pull a chair towards you. If you apply very small force, it is not going to come. But you are applying a force. No, it should come. No, it is not coming because it was on the ground for a long time. It wants to stay with the ground. Say they are friends now. They were touching each other for a long time and say like they are now friends. They want to stay. This is called inertia. That word is out of syllabus now. Simply it wants to stay. When you apply a force between contacting surfaces of chair and the ground, a special force creates against your pull, against your force. This force is called friction. This friction cancels your force. In other words, balances your force. When you increase your force, friction also increases. If you can overcome friction, because friction has a maximum limit, next week we will talk about it, it is called limiting friction. If you exceed this maximum limiting friction, then it has to come towards you, because you are creating an unbalanced force. Say friction is 100, your force is 110, now it has to come. Why? You are creating an unbalanced force. Okay. So if this table is coming, what can you say about forces? Balanced or unbalanced? Unbalanced. If it is not coming, what can you say about forces? Balanced. Right. Let's read it. As shown in the picture, ready? We apply a small force on table. First it does not move. Reason is, a resistance force called frictional force occurs between bottom of its legs and the ground. This frictional force becomes equal to our force. Then forces are balanced. No motion. If we apply a force greater than the maximum frictional force, then an unbalanced force forms. An object moves towards the net force of unbalanced force. Right. So now you know what are balanced forces, what they do. You know what is an unbalanced force, what they can do. Right. Okay. So which forces are really helpful for us? Which forces are really helpful for us, balanced or unbalanced? If you say unbalanced forces, your chair would get angry and break and fall you down. Now you are sitting there, balanced forces help you. Balance forces helping you. Balance forces are helpful. Actually, I just asked that question so that you can think this way, right? Balance forces also are helpful, unbalanced forces also are helpful. But which force can change this world, change things? Unbalanced forces. Right? Simply, things can be changed. States of motion can be changed by unbalanced forces, but both forces are very helpful, very useful. Right. Now, Newton's first law. Read karanne ba ahangin. Hari, first we take it into our head. Secondly, we note why. Why do we note secondly? Because we are going to forget soon, that's why. Ready then? Newton's first law. Muth read karanne ba, kiyawanne ba ahangin. Newton's first law. Though we say Newton is not a friend of mine, great scientist kenek, Sir Isaac Newton. But we don't write exam day Mr. Newton. Mr. Newton, Newton sir, Sir Newton, just Newton. N-E-W-T-O-N. N should be capital. Hari? Api Newton kila gino agauroya nevi. Api kiyana Newton kila. Hari? Okay. Right. Newton's first law is talking about two types of objects. One is like you, stationary objects. Hari? Newton's first law is talking about two types of objects. One is stationary objects. Second is objects moving with uniform velocity. Objects moving with a particular velocity, but uniform velocity, same velocity. Maybe like meteorite, asteroid, something like that. Okay? Or spacecrafts traveling in the space after switching off the engine, uniform velocity. Hari? Yeah. Newton's law, first law, is talking about which kind of objects? Either objects at rest, stationary objects. Secondly, objects moving with uniform velocity. Me දැන් මොලුවට ගන්න Newton's law එකේ කතා කරන්නේ objects දෙකක් ගැන. First law එකේ. එක්කෝ නැවතිලා ඉන්න එක්කෙනෙක් ගැන නැත්නම් එකම velocity එකෙන් යන එක්කෙනෙක් ගැන. Okay, now remember, exam paper is when talking about stationary object, it can be Newton's first law. When paper is talking about an object moving with uniform velocity, most probably the law applicable is Newton's first law. Harida, it is not talking about accelerating objects and decelerating objects. Accelerating objects, decelerating objects are in second law. Me දැන් මොලුවට ගන්න. හරි මේ මාර වැදගත් මේවා හරිද? Right. එහෙනම් Newton's first law is talking about which type of objects? Stationary objects, objects at rest, and objects moving with uniform velocities. Right. Newton's first law states that, not in our laws words, using simple words. Simple words වලින් කතා කරමු ඉස්සෙල්ලා. Then we come to capital words. Capital නෙවෙයි, standard words. Right. Newton's first law is telling us that if we do not apply an unbalanced force, if we do not apply any unbalanced force, do not apply කියන්නේ අපි ඒ චිට් එක අපෝ යන්නකෝ යටම අපෝ යවන්න චිට් එක යවන්න චිට් එකක් ආවනේ අපෝ යන්න යවන්න මම හිතන්නේ යා නිව්ටන්ස් ෆෝර්ත් ලෝ එක හොයාගෙනද කොහෙද යවන්නේ දැන් මම චිට් එක ගන්නවා ඇවිල්ලා යවන්න අපෝ යන්න ආපුතෙන්ට යවන්න ඔයාම තියාගන්න ඔය පිරිනමයිට චිට්ස් යවනවා මොනවද අපෝ ක්ලාස් එකේ ගිහලා චිට් එක යවගන්න හරි නිව්ටන්ස් ෆෝර්ත් ලෝ හොයාගෙනද කොහෙද අහගෙන ඔලුවට ගන්න right නැත්නම් ඕක ගියාම තව එකක් යනවා තව එකක් යනවා හයි යනවා අන්තිමට හයි යනවා right දැන් මොකද කිව්වේ Newton's first law says that හොඳට අහන් ඉන්න if we do not apply any unbalanced force හරිද law says that stationary objects remain at rest forever. Objects at rest ඒ පැත්තේ නිව්ටන් නෑ ඒ පැත්ත බලන්න බෑ හරි objects at rest ඒ පැත්තේ නෑ නිව්ටන් නෑ ඒ පැත්ත බලන්න බෑ ඔලුට ගන්නවා අහගෙන objects at rest remain stationary forever කියලා කියන්නේ මම නිකන් කිව්වේ objects at rest stay stationary stay at rest. Moving objects which are moving with uniform velocities, they keep moving at the same uniform velocity. We also can say that නේ අපිත් එක දන්නවනේ but unfortunately Isaac Newton has found it නැත්තම් කියන්න තිබ්බනේ ඔයාගේ නම දාලා කියන්න තිබ්බා චිට් එක දාලා මගේ ලෝ එක my law number 1 හරි මොකක්ද කිව්වේ ආයෙ බලමු simple words වලින් if we එහෙම ලියන්න හේවා if we do not apply an unbalanced force objects at rest remain stationary objects in motion continue to move at uniform velocities හරිද අපි unbalanced force එකක් දැම්මේ නැත්නම් නැවතිලා තියෙන දේවල් නැවතිලාම තියනවලු දැනට යන ඒවා ගමන් කරන ඒවා ඒ යන ස්පීඩ් එකෙන් velocities වලින්ම දිගටම යනවලු can you understand that the fact mentioned behind this story is that nothing is changing, nothing is going to change if we don't apply an unbalanced force stationary things remain stationary, no change, moving things move at same velocities, no change, got it? And because if you want to change something we have to apply an unbalanced force. If we don't apply any unbalanced force nothing changes here. Harida, right? Now let's add scientific terms to this. Newton's first law says that ඒ පැත්තේ නිව්ටන් නෑ හරි මෙහෙ බලන් ඉන්න ඕන Newton's first law says that දැන් හරියටම කියන්නම් until an unbalanced force is applied on it කිව්වේ කාටද නිව්ටන්ටද on Newton නෑ නිව්ටන් නෙවෙයි until an ඔලුවට ගන්න දැන් using scientific words until an unbalanced force is applied on it stationary objects remain at rest objects in motion continue to move at uniform velocities. What's the first part? ලියන්න හැම ඔළුවේ ලියාගන්න ඉස්සෙල්ලා හරි මොකද්ද කිව්වේ until an unbalanced force is applied on Newton is applied on it. You think stationary objects will remain at rest. The objects at rest remain stationary. අනිත් එක්කන objects in motion ඒගොල්ලෝ මොකද කරන්නේ continue to move at uniform velocities. ඇයි cities කියන්නේ? objects නේ. They have different velocities නේ. They maintain their velocities. Right. හරි. හොරෙන් ලියුවානේ. හරි. ආයෙසර බලමු මොකද්ද කියන්නේ? until නෑ මෙහෙමයි. අපි මෙච්චර කල් so far we were taking, our habit is taking notes. Now you have to change it. You should try your best to take things into your head. If you start today, little by little you can improve it. Okay? Grade 10, grade 11, A levels උත් තියෙනවා. හරිද? එහෙනම් in classes, maybe after today you tried your best to complete your note. Yeah, you have to do it. But before that, try to take into your head, you can. Little by little you improve. Right? We take note of course. Why? Because we are going to forget, no? ඉස්සෙල්ලා ඔලුවට ගන්න පුළුවන් තරම්. ක්ලාස් එකේ පාඩම් කරගන්න. can. පුළුවන්. හරි? I shared one comment නේ මට ආව WhatsApp message එකක් screenshot එකක් දාලා දැම්ම ඕගොල්ලන්ට නේ 11 වසර අයියා කෙනෙක් කියලා තියෙන දැක්කනේ ඒක දැක්කේ නෑ මානව WhatsApp group එකේ තියෙනවා මේ he got the highest marks section එකේ highest marks very happy and when he joined class in when he was in grade 9 I think 40s ගානක්ලු තිබ්බ දැන් 93 ද කොහෙද අරගෙන එන happy එකේ message එකක් දාලා තිබ්බා මම මේක දැම්ම group එකට හොඳයි කට්ටියට ඒක බලන්න හරි 40 ගානක් අරන් තියෙන්නේ දැන් මේ සැරේ section එකෙත් highest මරගෙන පුළුවන් එහෙම ගන්න බැරි නෑ හරි if you want try කරොත් පුළුවන් සාමාන්‍ය ක්ලාස් එකේ මේ පන්තිනේ 11 වසර 3 වෙනි පේලිය විතර ඉන්නේ සාමාන්‍යයෙන් හැමදාම එහෙමයි මාව කණ්ඩ වගේ හොඳට අහගෙන බලාගෙන ඉන්නවා hina වෙන්නවත් නෑ විරුවක් කරත් hina වෙන්නේ නෑ හරි දැන් තමයි තේරෙන්නේ ඔක්කොම ටික අරගෙන ඔලුවට try okay හරි one last time ඒව තමයි නිකන් අපිව කණ්ඩ වගේ තමයි ඉන්න ඕන හරි මොනවද වචනයක් දාන්නේ ටක් ගාලා අල්ල ගන්නවා මම කියන්නේ ටක් ගාලා ලියා ගන්න ඕනේ මේ කියන්නේ ටක් ගාලා අල්ල ගන්න ඕනේ right Newton's first law බලමු what is it until an unbalanced force is applied on it objects at rest remain stationary objects in motion continue to move at uniform velocities hari මෙහෙමයි meaning you have to take into your head and to write it correctly you have to catch these words also තේරුම ඔලුවට ගන්න හැබැයි මේ වචන වලින් ලියන්නත් ඕනේ ලෝ එකක් නේ ලෝ එකක් ඉඳලා right let's write until and what to write there unbalanced force until an unbalanced force until an unbalanced force right next part I have given is applied on it hari second line bodies at rest remain stationary bodies at rest remain stationary bodies at rest remain stationary right third line and bodies in motion continue to move at uniform velocities plural uniform velocities not uniform velocity uniform velocities because objects they have different velocities they maintain all those velocities without any change harida so why did I break into 3 lines because there are 3 points here one is saying that until an unbalanced force is applied on it secondly objects at rest remain stationary thirdly objects in motion maintain uniform velocity so there are 3 facts that's why I broke into 3 lines හරිද එතකොට ඔලුවට යනවා වැඩි දේවල් තුනක් තිබ්බා there were 3 things to mention ඔලුවට එනවා නිකන් that's why right now application side according to this there's a blank don't write anything just dots එකක් දාලා තියෙන්නේ according to this what can you say about the forces acting on followings what can you say about the forces acting on followings but you can't write forces acting are good forces acting are bad forces acting are large small one way what would you write I want to write forces acting are balanced or unbalanced අනම්මනම් ලියන්න එපා force එක හොඳයි force එක ලස්සනයි ඕක නෙවෙයි force is unbalanced or not that's what I want you to write හරිද right Plan now. What can you say about the forces acting at following? Say again, balanced or unbalanced, you decide. First one, when an object is at rest. Read, decide. When an object is at rest, what can you say about forces acting on it? කියන්න එපා හිතන්න. When an object is at rest, what can you say about forces acting on it? Balanced or unbalanced? Decided? Balanced. Because it is not changing. Like no force, balanced. Okay, you can write there. Forces acting are balanced. You can write there. Forces acting are balanced. නිකම් balance කියලා දීලා කමක් නැහැ ඉතින්. Forces acting are balanced. කම්මැලිමයි balance කියලා ලියයි ඒත් කමක් නැහැ. Forces acting are balanced. You know, last year I gave little longer, like forces acting on it are balanced. මේ පාර තව ටිකක් කොට කරා. Forces are balanced වගේ පොඩ්ඩක් අඩු කරා. ඒ කියන්නේ when we reduce number of words, most of you can focus well. ඒකයි උත්තර ඕනට විදිහ දිග වැඩි වුණාම මතක තියාගන්න අමාරුයි. හරි. ඒතර forces are balanced. Second one, when an object moves at uniform velocity. Uniform velocity, what can you say about forces acting on it? They are hitanda uniform velocity. No change ne, uniform. That means like no force. Forces are balanced. So you can write forces are balanced. Nathan just balanced. Harne. Forces are balanced. When I say forces acting on it are balanced too long. When I say forces are balanced, can understand. ඕනට වැඩි long sentences දෙන්නත් හොඳ නැහැ. හරි. එහෙනම් forces are balanced. Third one, when an object accelerates. Accelerates means velocity is increasing. What can you say about forces? Balanced or unbalanced? Accelerating, velocity is increasing, changing. Balanced or unbalanced? Must be unbalanced. Hari, පොඩ්ඩක් ඉන්න. I am going to add something last to this answer later. Hari, I am going to add something to the last part of this later. So don't take full space. Taking like half a space or quarter, you write forces are unbalanced. Memelian. Forces are unbalanced. Forces are unbalanced. Forces are unbalanced. හරි තාජුට්ට ලියන්න දිනවා දැම්ම නෙවෙයි. Forces are unbalanced. Right, fourth one now. When object decelerates. Object decelerates. Forces are balanced or unbalanced? Decelerates. Balanced or unbalanced? Unbalanced, because there is something changing. Right there once again. Forces are unbalanced. Forces are unbalanced. Right. Forces are unbalanced. Hari. Now I want you to think this way. 3 and 4 situations are opposite. One is accelerating, the other one is decelerating. How can we write same answer? There should be something different. No? Third one says accelerating, fourth one says decelerates. Increasing, decreasing, forces are unbalanced. But there should be something different. What do you think? How can we make it little different? හිතනවද විදිහ? One is accelerating, the other one is decelerating. Forces are unbalanced, but there should be a difference. What is it? It's a matter of direction. Think a little now. Hari, say someone is walking slowly. A three-wheeler is traveling slowly. Middle, a big lorry. Ne? Horn gano හරියන්නේ පොඩ්ඩක් ඇවිල්ලා හප්පනවා. What happens? Three-wheeler accelerates. Force we have to give towards the same direction. Then acceleration occurs. Ne? If we apply force, unbalanced force towards opposite direction, what happens to it? It decelerates. So in third one, unbalanced force acts towards the direction of motion. In fourth one, unbalanced force acts towards the opposite direction. That's the difference. හරිනේ? ඒ පැත්තටම force එක දැම්මොත් acceleration, අනිත් පැත්තට දැම්මොත් deceleration. Right. Now let's add for the third one. What was third one? Forces are unbalanced. Put a comma there and write comma දාලා ලියමු. Forces are unbalanced, comma. I'm thinking, can I use that word resultant force? I should not use. Ne? Still unit 4 ne. මම ඒ වචන දාන්න නැතුව I'm going to use simple words. මම මෙහෙම දෙන්නම්. Forces are unbalanced, comma. Forces are unbalanced, comma, acting towards the direction of motion. Acting towards the direction of motion. Acting towards the direction of motion. හරිනේ. Acting towards the direction of motion. Right. And now fourth one, when object decelerates, you have written that forces are unbalanced. Put a comma and write acting. Okay, නෙවෙයි. ඔක third එකට ලියන්න කිව්වේ. දැන් තමයි fourth එකේ ඉන්නේ. කපන්න එපා. ඔක වෙනස් කරගන්න යාළුවගෙන් බලලා හිවිසරේ. සෙට් එකම මේ ලියලා මේ හතරවෙනි එකට. ඕකනේ නිව්ටන් බල හිටියානේ. ඒකනේ උනේ. හරි. right. මං කිව්වේ third එකට තමයි කලින් එක. දැන් fourth එකට forces acting are unbalanced, comma, acting towards the opposite direction. එහෙම දාමු. acting towards the opposite direction. ඕක නෙවෙයි fourth එක දැන්. දැන් කට්ටිය 3 4 මාරු වෙලා. I am in fourth one now. What is fourth one? චුට්ටක් ඉන්නකෝ. යන්කෝ third එකට. Third one was what? Forces acting are unbalanced, comma, acting towards the direction of motion. Then fourth one, forces acting are unbalanced. නැත්නම් forces are unbalanced, comma, acting towards the opposite direction of motion. Acting towards the opposite direction of motion. හරි. සරයා සිංහලෙන් කියන්න නැත්නම් හරියන්නේ නැහැ. third එකට අපි කිව්වේ forces are unbalanced කියලා. හැබැයි force එක ඒ පැත්තටමයි තියෙන්නේ. fourth එකට කිව්වා forces are unbalanced හැබැයි තියෙන්නේ towards the opposite direction. දැන් හරිද? acceleration deceleration. Now someone is walking, you go and push, that person accelerates. You go and pull, don't go කියලා pull කරනවා. That person decelerates. Force is towards opposite direction. Hari. Right. Now there are 3 diagrams. I want you to think about forces, balanced or unbalanced. Right. There's a book on the table. Weight is downwards, reaction force is upwards. What can you say about forces? Forces are balanced or unbalanced? Think. Okay. Balanced or unbalanced? Balanced. Right there, balanced. Because what? Because object is at rest. At rest. නැත්නම් object is stationary. ඒකයි අපි එහෙම කියන්නේ. හරිද? අහුවත් හේතුවක්. How to find it? If something is moving at uniform velocity, balanced. If something is at rest, balanced. If something is accelerating, decelerating, unbalanced. එහෙම හොයන්න, that's how we find. හරිද? ඔලුවට ගන්න දෙයක් මම. Second one. What's going on? Plane is මොකද කියන්නේ? එක වචනෙන් කියන්න plane යන්නේ එන්නේ. plane යන්නේ එන්නේ. plane ඇඹිලා නෑ ඇඹිලා නෑ හොඳට තියෙන්නේ. accelerates. You can see it's going to take off. පේනවනේ? Look at the angle. Runway and plane is going to මෙහෙම land කරනවා ගිහිල්ලා මෙහෙම land කරන්නේ නැහැ සාමාන්‍යයෙන්. It's like taking off. That means acceleration. Acceleration. Right. If it is accelerating, what can you say about it? Forces are unbalanced. Ne? What to write there? We can write unbalanced force acting. Unbalanced force acting. Unbalanced force acting. Towards motion. Towards motion. Unbalanced force acting towards motion. හරිනේ towards motion. ඒකනේ accelerate වෙන්නේ unbalanced force acting towards motion. හරි because object accelerates නැත්නම් accelerating because object accelerates. හරි we can see it is accelerating, therefore we decide that forces are unbalanced and towards the direction of motion. Last one, oh my god, driver නිකන් සපත්තු දෙකෙන් පොළොව පාව කරනවනේ පාර. දැන් brake කැඩිලා දැන් කකුල් දෙකත් ඇතිල් වෙනවද කොහෙදනේ? Deceleration for sure, deceleration. That means forces are unbalanced. What can you say about direction opposite of motion? Right. Let's write there unbalanced force, unbalanced. Write the unbalanced force, then acting print kala thiyenne in the next line, right? Unbalanced force acting towards the opposite of motion, towards the opposite of motion giran liyaw, towards opposite of motion, right? Because objects මොකද කියන්නේ? Because object decelerates. ඕගොල්ලෝ නේද කිව්වා දෙන්න වෙලා යනවා කියලා. වෙලා ගියේ නෑනේ. මම පටන් ගද්දිම ආවනේ. මට චුට්ටක් වෙලා ගියා ඒකයි. නෑ ගොඩක් වෙලා යනවා කිව්වනේ. අවුලන්නේ ක්ලාස් තිබ්බේ නැද්ද? තිබ්බේ නෑ. පැනලාවද නැත්තම්? කලින් ඕගොල්ලෝ නේද කිව්වේ? මට මතක නෑ. කවුරු හරි කිව්වා මතකයි. If your school is keeping extra classes, just tell me, then I can repeat what I do from 2:45 to 3:15 or 3:30. I can repeat after 4:45. Hari? School එකේ classes දාලා පරක්කු වෙන අයට අපේ පැය දෙක ඉවරලා ආයිසරයක් පැය භාගයක් වෙනඩ රිස්පාක් කරලා කවර් කරලා දෙන්න පුළුවන්. මම එහෙම කරනවා හැම සැරේම. හරි? එහෙම පරක්කු වෙන අයට ඒ කියන්නේ වොරු වෙන්න එපා අපි එහෙම කරමු. Right. Because object decelerates. දැන් හරි. Don't look at Newton's second law. එහෙම කිව්වහම බලනවා මම දන්නවා. හරි. ආයෙ බලමු with Newton's first law we can step to that one. හරි. What is the meaning of Newton's first law? If there is no any unbalanced force, stationary objects remain stationary and moving objects move at uniform velocities. If there is an acceleration, that means there is an unbalanced force. If there is a deceleration, that means there is an unbalanced force. Right. Newton's second law says that acceleration which can happen, this acceleration is directly proportional to unbalanced force. That means when unbalanced force is higher, acceleration also is higher. When unbalanced force is low, acceleration also is low. It should be. Hari. So what is stated in Newton's second law? Acceleration of an object is directly proportional to unbalanced force acting on it. Harida? ආයෙ බලමු මොකද කියන්නේ? Acceleration of an object is directly proportional to unbalanced force acting on it. හරි. ඊළඟට මෙහෙම කියනවා. What do you think? When we apply our unbalanced force, if object is heavy, very heavy, can it accelerate easily? Or when it is not heavy, light in weight, can it accelerate easily? Which one can accelerate easily? Heavy objects, light objects. Heavy objects, light objects can accelerate easily. You can think like this. There is someone like this walking. Can you go and push and accelerate? No. If you push, you will learn, you will experience Newton's third law. What is Newton's third law? කියලා දීලත් නෑ ඒක experience වෙයි. තව පොඩ්ඩක් කියන්නම් බෑ. If you try to push that person, you will get pushed to the opposite direction and you will fall. අර මනුස්සයා හැරිලා බලගෙන බලලා whatever. You are down. Okay, you can't accelerate. But if someone like me is walking, anyone can easily push. Acceleration will be high. See, acceleration is high when weight is low. Acceleration is low when weight is high. So, what do we call such relationships? Proportional තමයි. 7 seconds ඇනුම තත්පර 7යි මෙහෙම තිබ්බද අතර හතක් විතර. ඔකේ. නිව්ටන් දන්නවා නම් එහෙම හොයාගන්න එක නෑ. only Newton's first law. ආයෙ laws හොයාගන්න එක නෑ. අනුන් ගන්නවා කියලා දන්නවා. හා මාස්ක් එක දාන්න අරින්න ඕනේ ඈනුවනේ. මාස්ක් එක දාගෙන මට කොහොමද ඈනුමට දැක්කේ? මාස්ක් එක ඉස්සරින් අත අල්ලගත්තා මෙහෙම. You forget that you don't have a mask and you forget that you are having a mask. ඈනු මේවත් ඉස්සරින් මේ මත අල්ලගත්තා. I know. හරි හරි. ඇතුලේ වැඩ. Okay. So what was the second part? Acceleration is high when weight is low. Mass is low. What do we call such a relationship? What proportional? Directly නම් නෙවෙයි එහෙනම් inversely proportional. Inversely proportional. හරි. So second one says acceleration of a body is inversely proportional to the mass. නැත්නම් mass of the object. හරි. What was the first one? Acceleration was directly proportional to unbalanced force while inversely proportional to the mass of the object. තව සරයක්. ඔන්න අහගන්න. Acceleration of an object is directly proportional to the unbalanced force acting on it while inversely proportional to the mass of the object. නැත්නම් mass of the object. හරිද? ලේසි නේ? දැන් මොලොට ගන්න වැඩේ ඉවරයි. Right. Acceleration of an object is directly proportional to the unbalanced force acting on it while inversely proportional to the mass of the object. Peli thuna ya. Acceleration of an object. Number 2 is directly proportional to the unbalanced force acting on it. Number 3 while inversely proportional to the mass of it. හරිද? තේරුම ඕනමයි වචන ටිකත් අල්ල ගන්න ඕන. ලෝ එකක් නේ. That's why. හරි. But I have given in 2 lines නේ. Come on නේ. The blank of a body is directly proportional to the hari. What is it? Acceleration. Right there. The acceleration. Just one word, acceleration. Liva. Kalimalila. The acceleration, right? Hari. Then of a body is directly proportional to the what? Unbalanced force. Unbalanced force. Unbalanced force. Actually it is called external unbalanced force, but ordinary level, O level, just writing unbalanced force is enough. But don't write force. Force කිව්වොත් මදි unbalanced වෙන්න ඕන. Unbalanced force. හරි acting on it, comma while it is inversely proportional to its MASS. Right there, MASS. Right. Then I have described in inside brackets this way. When there is an unbalanced force, objects accelerate. This acceleration is high when the force is high. It is low when the force is low. Acceleration is low when its mass is high and acceleration is high when its mass is low. Simple. Now this word expression we are going to express using some symbols. Symbols ටිකක් දාලා ලියන්න යන්නේ. හරිද? That means for acceleration simple A, unbalanced force capital F, mass simple M. Right. How to write it? How to write it using symbols? මෙන්න මෙහෙම ලියලා හැයි. Okay, I am going to give you 2. You tell me both correct or which one is correct. Right. This says, okay, one says this one. Next one, acceleration is directly proportional to the force. What is correct? You are free, you decide first one is correct or second one is correct or both okay. Otherwise exam day you are going to think this which one is correct. Or if you got this in MCQ paper, then you are in a big trouble. Which one is correct? This one or that one? මොකද කියන්නේ? මෙයාද වැඩියෙන් හොඳ මෙයාද වැඩියෙන් හොඳ. Say you have to decide one. One is correct. Which one? First one. Vote කරමු බලන්න පොඩ්ඩක්. First one. යන්තම් පේන්නේ තියෙන vote කරන්න. ඒගොල්ලෝ දිහා බලන්න එපා. ඒගොල්ලෝ මොකටද vote කරන්නේ? හරි. Second one. ඔව් දෙකටම එහෙම බෑ. දෙකටම අත උස්සනවා. එහෙම බෑ. ඒකටත් එයාටත් කැමති මෙයාටත් කැමති එහෙම බෑ එක්කෙනා. හරි. Which one? Hurry. Remember this way. Law says acceleration is directly proportional to unbalanced force. මේ තියෙන්නේ acceleration is directly proportional to unbalanced force. මෙයා තමයි හරි එක්කෙනා. First එක්කෙනා. එයාව තමයි ලියන්න ඕනේ. Remember, even I had this doubt. Which one is better? ටික දවසෙකින් අමතක වෙනවා. කොයි එකද හරි කියලා. හරි. I was finding a method and this is what I found. Law says acceleration is directly proportional to force. So A alpha F. ඔයා ලියාගත්තර ගමන් නැහැ. හරි. Law එකේ කියන විදිහටම ලියුවාම හරි. Acceleration is directly proportional to force. Otherwise exam day some of you will write this. මෙහෙමයි ලියන්න. හරි. So write for the first one. මොකක්ද තියෙනවනේ statement එක. හරි. ඉන්නකො මම අනිත් එකත් කියලාම පල්ලෙහාට බහින්නම්. Second one, acceleration is inversely proportional to mass. So you know this way we have write acceleration is inversely proportional to mass of it. How can we show inversely proportional to mass? This is directly proportional. How can we show inversely proportional? මෙහෙමද? No. This is what we remember. This is what we write. Remember, we can't write acceleration is inversely proportional to mass. We can't write acceleration is inversely proportional to mass. What we write is acceleration is directly proportional to inverse of mass. Acceleration is directly proportional to inverse of mass. That means acceleration is directly proportional to inverse of mass. So first one is this, second one is this. Okay, complete. Take your page number 2, complete. The last two. Acceleration is directly proportional to force. Write in big letters A alpha F. Yeah, in front of that you can write that also and you can put a cross there. F alpha A. එකක් ලියන්න. ඒකල වැරද්දක් දාන්න. Write F alpha A and put wrong. It is wrong. I can know either. Your first one is A alpha F ne. In front of that you write second one also and put a cross. Again, don't write that. It is wrong. කියලා කියන්නේ. නැත්තම් ඕගොල්ලෝ ඒක දන්නේ නැහනේ. You think that both okay I can write any කියලා හිතයි. දැන් වැරද්ද පෙන්වුවා. හරි? How to remember that one? You convert word by word into symbol form. Acceleration is directly proportional to force. You get it? හරිද? Right. Second one, acceleration is inversely proportional to the mass. Write the second one. A alpha inverse of m. ඔන්න ඔහමයි ලියන්න. Right. දැන් චුට්ටක් ඉන්න up to now okay ne. So far so good. Next page is going to confuse you. Going to kill your confidence. Hurry, because there are certain things that you can't understand, and remember you don't have to understand that one. හරිද? මේ ඊළඟ page එක දැක්කම පොඩ්ඩක් upset වෙනවා කට්ටිය. ඕන නැති දෙයකට upset ගන්නයි. ඒ කියන්නේ after these two steps there are few more steps and some of those steps you can't understand. Don't understand. Then we have to remember. No, you don't have to remember also. And finally we are going to get an equation. That equation you have to remember. හරිද? මේ steps ගොඩාක් තියෙනවා නේද? සමහර ඒවා තේරෙන්නේ නැහැ. සමහර ඒවා මතක තියාගන්නත් බෑ. try කරන්නත් එපා. වැඩක් නැහැ. අන්තිම එක්කෙනා ඕන F equals ma ඕනේ. But I describe everything, otherwise it is bad for some of your confidence. සමහර හිතන අයියෝ we didn't do this part. මේක ආවොත් ඉවරයි. මැරෙයි කියලා හිතනවා. ඒ නිසා කරනවා. හරි? right. ඔන්න බලන්න ඉන්න. Page number 3. First line. Acceleration is directly proportional to force A alpha F. Hurry. Once again let's write. මෙහෙම ලියනවා. A alpha F. Second one. Acceleration is inversely proportional to the mass. A proportional to inverse of mass. හරිනේ. Then look at the third one. Only third one. Therefore A alpha F over m. We can combine these two together. Then we get acceleration is directly proportional to force and inversely proportional to mass. ඒකත් හරිනේ. Third line you can understand. What is on right hand side? What is on right hand side? Maybe that you can't understand. මේ දකුණු පැත්තේ තියෙන එක්කෙනා තේරෙන්නේ නැති වෙයි. මම කියන්නම් මොකද්ද උනේ කියලා. If you compare left hand side one and right hand side one, can you see simple A is present in both? මෙයාගෙත් තියෙනවා A, මෙයාගෙත් තියෙනවා A. Yes or no? Yes. F over M also available in both. Yes or no? Yes. Now what is missing? What is missing? Alpha missing. හරිද? මෙන්න මේ directly proportional sign is missing. Instead of this, certain things have come. What came? What came? හොඳට බලන්න what came? This came. Other than that, this came. And the word constant came. Oh, then the constant came. What is this? It is a technique in mathematics. For our calculations, we need equal in between left hand side and right hand side. මෙහෙම එකක් තියාගෙන ගණන් හදන්න බෑනේ. කොහොමද හදන්නේ? බෑ. We need this one. So in mathematics, if you want to remove this proportional one and if you want to put this one, there's a way. What is it? You remove this proportional one, you put equal, but you have to multiply its partner by a constant. By a particular constant. Just listen. තේරුම් ගන්න ඕනේ. හරි මේ scientistලා කරන වැඩ අපිට ඕක කරන්න යන්න බෑ. හරි they have found an equation for us. That's enough for you. But I am just telling how they got it. Right? So they wanted to remove this one for calculations, and according to that mathematical procedure, you can remove this red part, but you have to add all these red parts. So they added. So this one we can write like this thing. A multiplied by constant equals F over M. මෙන්න මේ රතු පාට එක්කන අයින් කරගන්න ඕන. අයින් කරන්න පුළුවන්. හැබැයි මේ සෙට් එකම දාන්න ඕන දානවා. ඔන්න දැම්මා. හරිද? Don't remember මේව මතක තියාගන්න නෑ. පාඩම් කරන්නේ නැහැ. ඕනේ නැහැ. Sure ද? Sure එකට ඕනේ නැහැ. Right. Then we rearrange this one. We subject constant and then you get next line. What is it? මෙයාව අපි subject කරලා ලියනවා constant දානවා මෙතෙන්ද. You know constant equals F over M. It was like this no. මෙහෙමනේ තිබ්බේ. When you subject constant, this A should go down. Again this A should come here. Then when you write like that, can't understand. Tattu building එකක් වගේ නේ. Therefore we write this one as F slash M. Same නේ. F divided by M divided by A. That is your left hand side one. Right? Constant equals F slash M divided by A. මේවා ගණන් ගන්න ඕනේ නැහැ. Then left hand side, right hand side we interchange, exchange and write. Then we get F slash M divided by A equals constant. වම දකුණ මාරු කරා constant. හරි. Then last step. Then scientists defined a special unit called Newton. After defining that unit, somehow difficult for you to understand, they came up with what we want. What is helpful for us? What is it? F equals ma. This is what you need. So let's read and find out how this became this. පාඩම් කරන්න යවුවා නිකන් බලනවා විතරයි. right මොකද කියන්නේ? Unit of force Newton is defined as the force needed to accelerate an object with 1 kilogram mass by 1 ms minus 2 is 1 Newton. ඒ කියන්නේ scientists defined the unit. What was the unit? Newton. And they said 1 Newton කියන්නේ 1 Newton means hari 1 Newton is the force needed to accelerate an object which is 1 kilogram by 1 ms minus 2. මේක තේරුම් ගන්න දාගන්න එපා වැඩක් නැහැ. හරිද? This is from this. හරි මම මෙහෙම කියන්නම්කෝ. F equals ma is our calculation equation. Finally you get force. And force comes 1 Newton. තේරුම් ගන්න බලන්න පොඩ්ඩක් ඈ. Force comes 1 Newton when mass is 1 and acceleration is 1. Yes or no? Yes. Then 1 into 1 comes 1. Therefore they say 1 Newton is the force needed for 1 kilogram mass to get acceleration 1 ms minus 2. හරි එහෙම තමයි. ඉතින් ඒගොල්ලෝ කියනවා 1 Newton කියන්නේ force එක kilogram එකක් acceleration එකක් ගන්න apply කරන්න ඕන කියලා කියනවා. ඉතින් don't remember that one ඕනේ නැහැ ඒක. Hari, got it? So what is mentioned there? The force needed. Mekath balanna. The force needed F to accelerate an object with 1 kilogram by 1 ms minus 2 is 1 Newton. Hari, ඉතින් ඔව් තමයි. වැඩි තියෙන්නේ මේ when these things are there we get fully upset. Upset කරගන්න එපා. තේරුම් ගන්න නැහැ මේක. Just they have mentioned how 1 Newton came. පාඩම් කරන්න එපා. Therefore this constant becomes 1 Newton. Then we can rewrite this as F equals ma කියලා කියනවා. මෙන්න මෙහෙම this becomes 1 මෙන්න මෙයා 1 වුණා. Then this a you can send to that side. Then left hand side is F divided by m. Then this m you can send to that side as a multiplication. Then what is it? F equals 1 into m. That means F equals ma. ඔන්නෝම ගන්නවලු. හරි එහෙනම් ගමු ඉතින් එච්චරයි. ගමු. Right. Now I want you to take highlighter and highlight these lines. Highlight this one. Have to remember. Highlight කරන්න. මම කියන ටික විතරයි. And only these you should know. Others you don't have to know. That's what I am telling. Highlighted the හරිද? මම කියන ටික විතරයි කරන්නේ. This one. Then second line, highlight this also. This also. Then third line, left hand side. මෙන්න මෙයා. මේ මෙයා ඉන්නවා. මෙයාවත් highlight කරන්න. Third one, left hand side. Then take your pen or pencil, cut what is in front of it. එක එකකින් කපලා දාන්න. ඒකේ තියෙනවා a into constant equals f divided by m. කපන්න. හොඳට අහන් ඉන්න. a into constant equals f divided by m. Cut it using a line. පාඩම් කරන්න try කරන්න එපා. Now last line, constant equals f divided by m divided by a. Cut that also. Hari. In front of it, f slash m divided by a equals constant. Cut that also. එයාවත් කපලයින් කරන්න පාඩම් කරන්න ආය. හරි. Then there are two lines. Unit of force is defined as. Cut those two lines also. යකෝ ඔක්කොම ටික කපලයින් කරනවානේ. ඔව්. අයින් කරනවා අපි. හරි. ඊළඟට therefore f divided by m divided by a equals 1. Cut that also. හරිද? කියන ටික විතරයි. හරි. Don't cut last one f equals ma. දැනටම කපලා ඉවරයිද නැහනේ? නෑ. ඒක අපිට ඕනේ. හරි. Now I have given, look at this space here. For you to write in big letters f equals ma. තඩියට ලියන්න අන්නේ space එකේ f equals ma. මේම ලියන්න ඕනේ නෑ. ඔය ලියලා දාන්න. හරි. f equals ma. Right there, f equals ma. Harida? Right. Hari. Now what you need is this one, this one, this one and that one. Happy now? Hari? Otherwise, so this is my experience. Hari? When I was studying physics, I didn't know that these parts are not necessary. So I tried to remember every line. Wasting long time. Finally I realized that these are useless. And some students, if you are unable to remember, you just skip this whole lesson. මේ මුළු පාඩමම සමහරව අතාරිනවා. ඇයි ඒ? මේ දෙක තුන තේරෙන්නේ නැහැ කියලා. තේරෙනවද? අපරාධේ බොරු වැඩක් ඈ. හරි. එහෙනම් cut and remove these things and remember, but you remember these. This means what? Acceleration is directly proportional to force, acceleration is inversely proportional to mass, and acceleration is directly proportional to force while inversely proportional to mass. And for your calculations, you need f equals ma. ඔන්න හතර මතක තියාගන්න ඇති. ලේසි නේ වැඩේ. හරි. එහෙනම් only 1 2 3 4 things. First and second already know. When you combine them, you get third one, and last one is for calculations. හරිද? Right. ඔච්චරයි ඕනේ. That's what you want. Now we do exercise and we can come to Newton's third law. Half an hour තියෙනනේ. Half an hour තියෙන්නේ. Right. අපි එකක් කරමු දැනට. එකක් නැත්නම් දෙකක්. Exercise 1. Exercise 1. Write suitable words out of lowest, medium, high for the acceleration under each given below. I know some of you feel very difficult in understanding this. These diagrams are very difficult for some of you. So that's why I want you to try. Read and try only question number 1. See whether you can understand. සමහරුන්ට මේ diagram පට්ට අවුල් මේවා දැක්කහම. හරි? ඒ දැකලා පුරුදු නෑ. ඒකයි අලුත් දෙයක්. බලන්න read කළා. Can you write just words නේ lowest, medium, high. බලන්න පුළුවන්ද කියලා try. Lowest, medium, high. So I don't help, you have to understand it. තනියම තේරුම් ගන්න බලන්න ඕනේ. මොකක්ද ඒවයි කියන්නේ කියලා. Just 1 minute. Liva. මේක රීඩ් කළා බලන්න කරමු. දැන් මම උදව් කරන්නේ නැත්තේ I want to improve your that skill. Reading, understanding, analyzing. Science paper එක ගැන හොඳ දෙනෙක් කියන්නේ තේරෙන්නේ නැහැ කියලා. paper එක තේරෙන්නේ නැයි. තේරුම් ගන්න උත්සාහ කළා නැහැ. රීඩ් කළා බලන්න පොඩ්ඩක්. I'll describe after 30 seconds. You have to look at these diagrams carefully and you have to write acceleration, lowest acceleration, medium acceleration, highest acceleration. That way you have to write. Then චොට්ටක් help එකක් දෙන්න. You know acceleration depends on two things. One is force, directly proportional. One is mass, inversely proportional. Force is given for these trolleys by what? Yes, for this trolley to travel, force is given by rubber band or rubber bands. And these rubber bands are straight, that means we have stretched. So actually given by stretched rubber band or stretched rubber bands. Harida? One band, one force. Two bands, double force. Harida? Right. So when you look at rubber bands, first one has one rubber band, second one has two rubber bands, third one has one rubber band. So forces are equal in 1 and 3, force is double in middle one. Harida. Now according to force, acceleration of first and third should be same, acceleration of middle one should be higher. Harida. Other than that, acceleration depends on weight, mass. First one is normal, second one is normal, third one has a mass loaded. මොකද්දෝ කළු පාට තඩි මොකද්දෝ තියලා. Should be heavy. When it is heavy, acceleration is low. Now when you compare 1 and 3, which one has more acceleration? First one. Why? Force is there, weight is not there. Low acceleration, third one. What about middle one? Acceleration is highest. Why? Two stretched rubber bands are there. Force is double and no weight also. හරිද? ඇදපු rubber band දෙකකින් ශක්තිය දෙනවා middle එකට. එයා බරත් නැහැ. එයා නිකන් පට ගාලා accelerate වෙයි. පළවෙනි එක්කෙනා එක rubber band එකයි accelerate වෙයි. third එක්කෙනා rubber band එක තිබ්බට එයාගේ තඩි බරක් පටවලා. එයාට accelerate වෙන්න අමාරුයි. Got it? Right. Now what are the words? First one අපි ඉස්සලම last one lowest. එතකොට first one medium, second one high. නැත්නම් highest හරි වචනේ දාන්න ඕනේ. Right. ලියන්න කියන්නේ lowest, high කොහොමද word එක? medium. හරියනවා first one high. නෑ. highest කියලා ගන්න නෑනේ. දැන් එහෙනම් medium, second one high, last one low. නෑ lowest. හරිද? So words are lowest, medium, high. High for middle one. medium for first one, lowest for last one. Harida. Then we are not going to do calculations now. I want you to circle 2, 3, 4 as homework. Because there are 3 more topics to cover today. අපි ඒක cover කරලා වෙලා තිබ්බොත් අද එකක් කරලා නැත්නම් 2 3 4 circle homework. ටික් කරන්න බෑ. ටික් කරන්නේ හරියට හැදුවොත් විතරයි. රවුමක් අඳින්න මෙහෙම මේක වටේට ප්‍රශ්න වටේට homework. හරි දාන්න එපා. හරි දාන්නේ හරියට හැදුවොත් විතරයි ඈ. හරි දැනට circle කරමු අපි. Right? Hari. Then Newton's third law. Newton's third law is very simple. You are experiencing it and now you can feel also. දැන් මේ පැත්තට දැනනවනේ. වාඩිලා ඉන්න පැත්තට මොනවද? නිකන් තද කරනවා වගේ දැනනවනේ. දැනනවා. Why? You are applying part of your body weight on the chair and chair is giving a force on that side. And Newton says this force is equal in magnitude and opposite in direction. ඒ කියන්නේ for every force there is a return force. This return force is equal in magnitude and opposite in the direction. ආයෙ බලමු using normal words for by Newton's third law එකයි සද්දයක් ආවේ. නේද? බොටල් එකෙන් force එකක් දුන්නා පොළොවට පොළොවෙනුත් දුන්නා force එකක්. හරි ආයෙ බලමු for every force there is a return force. It is equal in magnitude and opposite in direction. Hari ආයෙ බලමු මොකක්ද කියන්නේ for every force there is a return force. They are equal in magnitude and opposite in direction. මෙයා පොඩ්ඩක් හොල්ලන්න. අර Newton's first law මට මතක් කරලා දෙනවා. Until and unbalanced force is applied. ඕන දැන් ඔයා force එකක් දැම්මා. Stationary object system. හරි. Right. Let's use scientific words. I said for every force නේ. අපි ඔකට කියන්නේ for every action කියලා. There's a return force නේ. Return force is called reaction. So with scientific words, Newton's third law is for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. නේ කාගේරි කම්පියුටර් ගැහුවොත් චටාස් ගාලා අපිට වදිනවලු ඔව් පටාස් නෙවෙයි එතකොට equal opposite නෑනේ equal නෑනේ චටාස් නම් චටාස්ම තමයි චටාස් ගාලා ගැහුවොත් චටාස් ගාලා හම්බ වෙනවලු චටාස් හම්බෙද පටාස් හම්බෙයිද දන්නේ නැහැ වෙයි if you know Newton's third law you should give same force චටාස් නම් චටාස් isn't it now මේ කැන් එකක් නෑ නේ මම තල්ලු කරාට මම පේනවද කැමරා එකට පේනවද හරි මෙහෙම ඉඳගෙන නේ මෙහෙම හිටගෙන if I apply a force on sure නෑ කඩ වැටිද නේ on this one I am getting a force towards opposite direction why I give action I am getting reaction very simple action reaction I am standing now I am giving my body weight on this action this flow is giving me reaction very simple action reaction Newton's third law let's write that කොහොමද ලියන්නේ for every action leave for every action there is an and නෙවෙයි an හරි once again for every action there is an equal and opposite reaction hari once again for every action there is an equal and opposite reaction right Newton's third law so you have to by heart this you should highlight Newton's first law Newton's third law Newton's second law all later කටපාඩම් තියෙන්න ඕනේ තිබ්බටම මදි තියෙන්න ඕනේ right inside brackets for every force there is an equal and opposite return force let's see examples in very first example what is it we paste a plastic tube on a balloon and we set a cable through this plastic tube and we connect and we fill air into balloon and we release its mouth what happens Rubber membrane, balloon membrane pushes air molecules out. Air molecules push the rubber balloon towards the opposite direction. Harida. Second one also same. Let's read second one. What is action? Balloon pushing air molecules down. What is reaction? Air molecules pushing balloon up. Hari? Stretched rubber membrane pushes air out. This air pushes rubber towards the opposite direction, so it can travel. Last also same. Expulsion of air from an inflated balloon. Maybe you can get a diagram like this, and maybe you have to write what is action, what is reaction. මේ බැලුම දීලා කියන්න පුළුවන් action ලියන්න reaction ලියන්න කියලා. හරිද? તો ලියන්න මොකද්ද action එක? balloon නැත්නම් balloon membrane pushing air molecules out. Reaction, air molecules pushing the balloon towards the opposite direction. Right. This you can understand. These, they are sitting on trolleys, they are pushing each other. What happens? They get pushed towards the opposite direction. Swimming, what is there? Hands applying a force on water and an equal and opposite force exerted on hands by water. In other words, this man is pushing water, water is pushing the man's hands. Action, reaction. That's why if you are doing swimming, you have to grow your body muscles. A movement at all muscles, arms same or than then strongly you can push water backwards and water can push you. මන්තරයක් එහෙම ජප කරලා වතුරට පිවිනවා. එහෙලා පයින්නවා. යනවාද බෝට්ටු වගේ. එහෙම වෙන්නේ නැහැ නේ. You have to push water, then water pushes you. This also same. Rowing a boat using oars. We push water using oars and water pushes oars. Front. This one you know, when we keep an object on a surface, object gives weight down, surface gives reaction up. Rocket. Rocket is doubtful, especially when rocket is in the space. Rocket එක space එකේ තියෙද්දී some people argue how can Newton's third law work there in the space? Because space has no medium to push the rocket. Here rocket pushes air, air pushes rocket. Okay, after going to atmosphere, after going out from the atmosphere, who is there to push the rocket? Doubtful, ne? Therefore, I found a nice article on it and I put here. අපි එක read කරමු ඊට පස්සේ මම කියන්න. මේ බලන්න. ඒකට උත්තරේ මේ article එකේ තියෙනවා. මම ඒක දැම්මා. සමහරවිට ඔය doubt එක තියෙනවා. කොහොමද ඔක වෙන්නේ? Let's read. What does it say? A rocket travels in a space by using Newton's third law of motion, which states that for every action there is an equal and opposite reaction. When a rocket engine burns fuel, it expels high speed exhaust gases in one direction. According to Newton's third law, the rocket experiences a force in the opposite direction, propelling it forward. This allows the rocket to move through the vacuum or space, vacuum of a space, without need of a medium to push against. Rocket burns fuel and propels exhaust gases out. These gases push the rocket in the opposite direction. හරිද? එන්ජින් එක තෙල් පුච්චලා gases වගේක් එළියට විදිනවා. ආයෙත් චිට් එක යනවා. හරි. ඉරේසර් ගන්නේ. gases වගේක් එළියට විදිනවා. gases ටික rocket එකව තල්ලු කරනවා. මම යන්නම් තෝත් පළ කියලා. හරි? They go towards opposite direction. Got it? And that's how rocket can travel in the space without any medium. දුකෙන් නේ ඉන්නේ rocket එක කියන්න නැහැ කියලා. පේනවා. upset එකකින් ඉන්න පොඩ්ඩක්. Right. So remember some examples for Newton's third law. You may have to write 1-2 examples. Exam day. MCQ paper can give all these as examples, asking you to select what is correct, what is wrong. Right. 2 more topics to do. 15 minutes. MASS and WEIGHT. This MASS I call mass, sometimes mass. What is correct? The word mass is pronunciation. Mass is used for many things, but mass is only for grams, kilograms. So sometimes I use mass, sometimes I use mass. Right? Mass කියන pronunciation එක තව තව දේවල්ට පාවිච්චි කරනවා. ඒ හින්දාම වෙලාවට mass කියනවා. mass කිව්වොත් මෙයා විතරයි. ඒ හින්දා. හරි? right. ඔන්න අහගන්න. mass and weight difference grade 10 නේ. දන්නවා. I describe this in unit 2 also. එතනත් තිබ්බනේ gravity එහෙම මං කිව්වා. හරි. ආයෙත් කියන්න. හිතන්නකෝ මෙහෙම. ඔන්න think about your favorite biscuit packet. biscuit වෙන මොකුත් නැද්ද? හරි biscuit packet එකක් ගැන හිතන්නකෝ. හිතන්න කිව්ව විතරයි කියලා ගිල්ල වාටියේ. කණ්ඩ කිව්වේ නැහැ පොඩ්ඩක් මතක් කරගන්න කිව්වේ. Your favorite biscuit packet. නිකන් හිතමු your favorite biscuit packet has 10 biscuits only. 10 biscuits. Just imagination Imagine your favorite biscuit packet has 10 biscuits. How many? 10 biscuits. Say million atoms. කන සුද්ධ කරනවද? 10 biscuits. How many atoms? Say million atoms. මේක මතක තියාගන්න. 10 biscuits. මොකක්ද අට්ටුවක් දාලා කියන්නේ බිස්කිට් කියන්නේ මොනවා හරි. මොකක්ද ඔය කියන්න ගියා. හරි අහන් ඉන්න 10 biscuits නිකන් million atoms. Say when we weigh it here it is 100 grams. මතක තියාගන්න එහෙම ගමු 10 biscuits 100 grams 1 million atoms. හරිද? right. Is this biscuit packet heavy here? එයා බරයිද? heavy නැද්ද මෙහෙදී? නෑලු සමහරු. It is not heavy here. If we ask you to wear a loose trouser here, and if we put the biscuit packet into pocket and ask you to jump, now tell me, heavy or not? Now heavy. now heavy නේ මතකයි නේ. එහෙම කිව්වම තේරෙනවා. හරි. heavy නේ? heavy. biscuit packet is going to go down with the trouser. that means it is heavy. හරි. it is heavy. right. 10 biscuits 100 grams million atoms heavy here. heavy means it has a weight. heavy කියන්නේ weight එකක් තියෙනවා. හරි. if we take this biscuit packet and you and trouser everything to space අභ්‍යවකාශය, how many biscuits will be there? 10 biscuits. how many atoms will be there? 1 million. Will it be heavy? You can float, biscuit float, trouser also floats. Not heavy. That means there is no weight, isn't it? There is no weight. Right. Here there is a weight. In the space there is no weight. You have heard that. The reason is on the earth we are experiencing a high gravity. And when gravity is available, weight is available. In the space when there is no gravity, there is no weight. Harine? That means what is weight? Weight is the gravitational pulling force. Weight is the force exerted by gravity on mass. When there are atoms, when there is something, gravity is pulling it down. This gravitational pulling force is called weight. Harida? Now what is weight? Gravitational pulling force. නැත්නම් weight is force exerted by gravity on objects. On a weight එක. Force exerted by gravity on objects can be called weight. හරිද? What is mass? mass is the amount of matter present in something. The amount of matter contained by something. I told you that there are 10 biscuits. So you can say mass is 10 biscuits. I said 1 million atoms. So you can say mass is 1 million atoms. But mass is measured in grams, kilograms. So more accurately you can say mass is 100 grams. Here 100 grams because there were 10 biscuits, million atoms. So when we take this biscuit packet to space, if there are 10 biscuits, if there are 1 million atoms, you have to say mass is 100 grams. Because mass is amount of matter, remember. Hari, what is mass? Amount of matter. Equive 10 biscuits, 1 million atoms. Oga tama mass kiyanne. But as a standard we measure in grams, kilograms. We can't see atoms. Atoms ganan karanna bæne. Grams, kilograms used. Weight is what? The force exerted by gravity on it. That's why when there is gravity, there is weight. When there is no gravity, no weight. And on the moon, what have you heard about weight? Weight is less than here. How many times? 6 times less. Why? Gravity is 6 times low. On a planet like Jupiter, what have you heard about weight? Weight is very high. Very difficult for spacecrafts to land, right? Because they are pulled by the planet. They go and crash. Say somehow they landed using parachutes. They can't come back. Why? Engine power is not strong enough to take it off. More powerful engine. Gravity is very high. Weight is very high. Okay. So then what is mass? Amount of matter, like biscuits, atoms, grams, kilograms. What is weight? Gravitational pulling force acting on mass. Okay, right. And mass is therefore independent, but weight depends on gravity, dependent. Right. What's the Sinhala name for mass? Skandaya. What is the Sinhala word for weight? Bara. In day-to-day life, we are actually using it incorrectly. We are misusing it. We weigh mass in kilograms. Completely wrong. No. We weigh weight in kilograms. නේද කඩේට ගිහිල්ලා හාල් කිලෝග්‍රෑම් එකක් කියලානවා බර නෑ බර weight is in newtons. It is mass. එහෙම කියලා මුදලාලියෙන් අහන්න එපා මට කිලෝග්‍රෑම් එකක් ස්කන්ධය දෙන්න. බැනුම් අහගන්න වෙයි හරි නේ කිලෝග්‍රෑම් එකක් ස්කන්ධය. පිස්සුදායි. right. Mass skandaya, weight bara, mass grams, kilograms, weight newtons. Right. 10 minutes only, yeah. Right. Mass is right there. The amount of matter present in a substance. The amount of matter. The amount of matter present in a substance. The amount of matter, matter, present in a substance. Right. Inside brackets write g, kg, grams, kilograms. Right. Next one, weight is right there. The force exerted by gravity. Exerted, E-X-E-R-T-E-D, the force exerted by gravity on an object. The force exerted by gravity on an object. Inside brackets? No, inside brackets only. I have given unit there. Unit capital N. You know N means Newton. Ne? Capital rolling N. Right. Then way to find weight. Way to find weight. Read කරන්න එපා අහන් ඉන්න way to find weight. That means someone ask you what is your weight? ඔයාගේ බර කීයද කියලා අහනවා. අහන්න එපා I උස්සන්නද? ඔබ to lift me. නෑ එහෙම නෙවෙයි. You can say 450, 500, 600, 800. Why? 800 kilograms? නෑ kilograms නෙවෙයිනේ. ඇහුවේ බරනේ weight නේ. What is the unit? Unit is newtons. But how can we say 600, 700, 800 likewise? Because Newton value is 10 times of your kilogram value, remember. Hari? If someone is 45 kilograms, Newton will increase 450. 50 kilograms, 500. 60 kilograms, 600. එහෙනම් ආයේ බර කීය දවුවාම අය උස්සන්න දහන්න එපා කියලා දාන්න. 600යි 700යි 800යි ආහන එක කලන්ත හැදිලා වැටේ. But you have to answer in newtons because asked what? Weight. Now how to convert, how to find weight from mass? This is how we find. This is what we use. Near this equation we didn't write anything else. Now it's time to write. F is unbalanced force, no? It is in newtons. එතෙන්ට ගිහිලා ලියන්න ඕනේ. M is mass, so mass. It is in kilograms. What is A? A is acceleration. ms minus 2. කතා කරන්න එපා පොඩ්ඩ වෙලාවයි තියෙන්නේ. හරිම වැදගත් වෙලාව මේ. තව විනාඩි 5ක් 10ක් තියෙනවා. මොතරම් අහන් ඉන්න ඕනේ. Right. Get back to this equation and write these units. Force is in newtons. Mass is in kilograms. Acceleration is ms minus 2. Acceleration ms minus 2. Ready there? ඕන්න හොඳට අහන් ඉන්න. We are going to find weight from mass. We are going to find weight from mass. Say your body is 50 kilograms and your weight is how much then? 500 newtons. How do we find it? This is how we find it. Again, F equals ma. This is u. How many kilograms u are? 50 kilograms. Do you know that your body is going to accelerate every time? If I jump from this down, won't I accelerate? I accelerate. You also. If your chair breaks, what happens? You accelerate down. That means every time there is an acceleration ready to act on our body. What do we call it? Acceleration due to gravity. Gravity is pulling us down every time. Therefore, if we make our body free, gravity accelerates us down. Sure නැත්තම් අර පඩි පෙලෙන් පොඩ්ඩක් යන ගමන් පැනලා බලන්න මොකද වෙන්නේ කියලා you can understand. හැබැයි ගොඩක් කුසකින් පයින්න බෑ. පොඩි තැනකින් මේ වගේ. හරි? Always gravitational force is acting on us. Therefore, we are ready to accelerate. And this acceleration is called in unit 2 acceleration due to gravity. How much is it? 9.8 ms minus 2, but we take it as 10. Can you remember one scientist proved that irrespective to size, shape, weight, this acceleration due to gravity is constant on everything, everyone. Galileo Galilei. He went to the top of Pisa Tower not to eat pizza. He dropped a small object and heavy object, and both came to the ground level same. That means acceleration due to gravity is constant. How much is it? 9.8. We take it as 10. Now according to this equation, if you want to find your weight, and you know now weight is the gravitational force acting on you. So instead of this gravitational force, I can write W, again weight. What is weight? Gravitational force acting on you and me, everything. So gravitational force we can write weight. M tamai. A, on all of us, acceleration acting is called acceleration due to gravity, mg. Therefore, F equals ma gives us another equation, W equals mg. Note karaganna epa. Because every time we have to start our answers using F equals ma, not from this one. අපි හැම වෙලේම අපේ උත්තර පටන් ගන්න ඕන මෙතනින් according to marking schemes. ඒකයි මේක ලියන්න එපා කිව්වේ. I have seen some questions starting from W equals mg. You check marking schemes, better you start from this one. First line this, second line this. Right. This way, if you want to find weight, you multiply your kilogram value by acceleration due to gravity 10 ms minus 2. You get your weight. That's why I told you, you multiply your kilogram value by 10 and tell it is your weight. Harida. Now tell me how to convert kilograms to newtons. Kilogram, you have to multiply by 10, you get newton. Hari? Kilogram newton කරන්න ඕන නම් 10න් වැඩි කරන්න මේ newton වෙනවා. Therefore, I have given this shortcut, kilograms to newton. How to do this? Kilogram value you multiply by 10, you get in newtons. Hari, let's read this story now about mass and weight. Right. Then, අපි ඉන්නේ way to find weight. Way to find weight. You can use this equation to find the weight from the mass and to convert right there kg to n. Kg to n. ලියමු අපි එතන. Kg to n. Hari. Then write inside this box F equals ma, therefore W equals mg. ඔය box එක ඇතුලේ ලොකුවට ලියන්න F equals ma, therefore W equals mg. ඔය තඩියට box එකක් තියෙනවා. ඕක ඇතුලේ ලියන්න F equals ma, therefore W equals mg. තියෙනවනේ ලොකුවට මෙතන box එකක් තියෙනවා. මේ තියෙන්නේ මේ F equals ma, therefore W equals mg. හරි. You can see here kg arrow n, right on that arrow into 10. 10න් වැඩි කරන්න තියෙන්නේ. Right. Now, how does it come? I described this, so please help me to finish this quickly. Because of weight capital W, substances fall towards gravity. When they fall, they accelerate according to F equals ma. anything falling towards the ground accelerates at the same rate of 9.8 ms minus 2. We consider it as 10 ms minus 2. When we take this acceleration as simple g, we can rewrite equation F equals ma as W equals mg. Weight of a substance is directly proportional to the gravity. Moon's gravity is 1/6 times low, therefore weight on moon is 1/6 times low as that on earth. On Jupiter, the gravity is very high and therefore weight also is high. When there is no gravity like in a space, weights of substances become zero and they start to float. Gravity decreases gradually when going up from the sea level, and finally there is no gravity. Right. We do exercise 1 and then we go to momentum. Right. Exercise 1. Tatparatihen karanne. The mass of a person is 60 kilograms. What would be the weight of that person? How to find? F equals ma. No need to write W equals mg. That also you can write, or even without writing you can do. Shall I show you how to do? First step is this. F equals ma. Secondly, gravitational force is called weight W equals, no need to write mg, because they are not going to give 1 mark for this and 1 mark for this. They will give 1 mark for this. We write that one, we get the first mark. Then we want W, we write W equals, how much is mass? 60 kilograms. Into how much is acceleration? Acceleration due to gravity is 10 ms minus 2. Only you can get your second mark. Thirdly, weight equals 600 in newtons. This way you can get your third mark. ඔහොමයි weight එක හොයන්නේ mass එක දුන්නාම ලකුණු තුනකුත් අරගෙන. හරි? Taking all 3 marks. Circle 2 and 3 and 4 as homework. හිමින් සැරේ හිතලා හදන්න. හැබැයි you are going to get about 3 marks. F equals ma, you should try to get first mark. Second step, third step, same way you try to do. හිතන්න දීලා ඊළඟ දවසේ කරනවා. Our very last topic, MOMENTUM. Our science has MOMENT also. In English, moment. In science, moment. Clockwise moment, anti-clockwise moment, like a seesaw later. Hari? This is called momentum. What is this momentum? This new word, momentum. Okay. Hari tannako mem. Fast 3-wheeler came out of road. What do you think? Can this fast moving 3-wheeler break a concrete wall? Most probably not. It is coming very fast. Baltiyak gahala kondarumak gahagena avilla happena concrete thap එක. It won't break. But very slow, derailed train, can't it break concrete wall? Can. පීලි වෙනම කෝච්චියක් හිමින් ඇවිල්ලා concrete බිත්තියක වැදුනොත් ඒක කැඩෙයි. How can you describe this difference? මොකක් කියලාද කියන්නේ? Can we say train was very strong? ටිකක් විතර හරිනේ, but 3-wheeler නම් strong නෑ, but made up of same material කියමුකෝ. But how can we describe this? Can we say train is very heavy, that's why? ඒකත් එච්චර හොඳයි. Can we say train came very fast, that's why? No, it was coming slowly. එහෙම කියන්නත් බෑ. Can we say train is big, that's why? ඔක්කොම හොඳයි, but not perfect. The perfect term is train had high momentum. 3-wheeler had very low momentum. That's the reason. So what is this momentum then? Is it a strength? Hey, heaviness? No. Momentum means if you multiply mass of a moving object, if you multiply mass of a moving object with its velocity of motion, what you get is called momentum. මෙයා අලුත් එක්කෙනෙක්, අමුතු එක්කෙනෙක්. හරි? Something is moving. You take its m in kilograms. It is moving, no? You multiply this with its velocity in ms minus 1. හරිද? එයාගේ mass එකයි එයාගේ velocity වැඩි කරොත් එහෙමයි. You get a new quantity. It is called simple p momentum. So momentum is mass into velocity, mass in kilograms, velocity in ms minus 1, then momentum is in not Newton or something, kgms minus 1, aluth unit kgms minus 1. Okay, you can note this equation. Inside this box, momentum, right? P equals mv. For exam also we write the same. P equals mv. Momentum equals mass into velocity. Write inside that box, not in the blank. Blank එක නෙවෙයි box එක ඇතුළේ ලියන්න. මම blank එකට උත්තරේ දෙන්න. අර box එක ඇතුළේ ලියන්න ඕන. ලියුවා? P equals simple m into v. Right units kg ms minus 1 kg ms minus 1. අපි තව විනාඩියක් නවත්තනවා. විනාඩියක් නැත්තම් දෙකෙන්. When you have to find momentum, multiply mass in kilograms with velocity ms minus 1. Your answers unit should be kg ms minus 1. This is called ගම්‍යතාවය, momentum. ගම්‍යතාවය සිංහලෙන් කියනවා. Right. Exercise 1 we do and we stop. Exercise 1. What's your first step? An object has a mass of 400 grams. What is the momentum of the object when it's moving at a velocity 5? Momentum. This is your first line. P equals mv. Now P equals m into v. First mark simple P equals m into v. On the first mark ek gatta hai. Don't write capital P. एक pressure එතකොට මෙයා simple P equals mass is 400 grams bare. You need kilograms. So you write 400. Show how you convert it into kilograms and write kilograms here. I have seen students writing grams here bare. 400 divided by 1000 kilograms into velocity. What's the velocity? 5 ms minus 1. 5 ms minus 1. Then you do your calculation, you get the answer. 0, 0, go. It is 20 divided by 10. 2 kg ms minus 1. Do this way, you can get full marks. මහලොකු දෙයක් නෙවෙයි. MV තමයි momentum කියලා කියන්නේ. අලුත් දෙයක් ගම්‍යතාවය. right? ලොකු එක්කෙනෙක් හිමින් ඇවිල්ලා අපේ හැප්පුණත් අපි විසිරනවා. පොඩි එක්කෙනෙක් නම් හයියෙන් ඇවිල්ලා හැප්පෙන්න ඕන. momentum matter එකක් තියෙන්නේ. Right, okay, second circle question. Circle second question. වචනත් වරදිනවා දැන්නේ. Circle second question. And past papers also you try to do. As I told you, this is not easy for some of you. So I give you 1 week, 7 days homework. දවස් 7ක් තියෙනවානේ. Read this and try to do. And the best day to do this is today. Because by tomorrow 50%, 60%, 70% gone. චුට්ටයි ඔළුවේ තියෙන්නේ. පුළුවන් නම් අදම කරන්න. හරි, by doing this you can improve you a lot yourself. So next week we should discuss this definitely all this, and then we do friction. Friction is one topic, just friction.